Okay, we are still solving systems. Why are these problems on your homework paper called systems? Look at your homework paper. Why are they called systems? How many equations do you see every single time? 2. A system is actually more than one. Coming on later in the week is bigger systems. But there's more than one. And we are going to solve these systems algebraically. Now, the systems we were solving last week were these kind of systems where we had linear equations. If you look at your homework paper, do you see that the homework paper has some x squareds on it? That's a parabola. The kind of equations we're starting today are a parabola and a line. Now, if you have a parabola and a line, how many intersection points could you get? 2, possibly. And so if you would turn over, oh, no, wait, this is on that same page, right? As I said previously, I think one of the things that was confusing you last week was jumping back and forth from different kinds of solution techniques. So I am not going to be using these steps. I am not going to be showing you how to solve this by substitution. I am going to show you by elimination. Now, don't mark out all the steps because you might want to look at those. But what I'm going to be showing you today is how to solve by elimination. Because when I surveyed my students and asked them, given a choice between substitution and elimination, which one do you choose? 90% of my students would choose, if they would probably choose neither one. But if that's not an option, then they would choose elimination. So now open to your next page. We're going to have a parabola and a line. There could be 2 intersection points. Now I need to change this. Obviously there's no intersection points, right? But that doesn't mean there's no solution. That means there's no real number solution. I could solve it and get a imaginary solution with an I in it. And occasionally we would have 1 solution point. Those are the 3 things that can happen if you have a parabola and a line. In example number 1, I have a parabola because x is squared, and this is a line because nothing is squared on that one. So, if I'm going to solve it by elimination, I need everything lined up, right? That's how you solve by elimination. So, I'm going to put my parabola down first, and then I'm going to put my line down, and I skipped a space right in here because I don't have an x squared here, so I'm just going to leave that blank, and then I'm going to line up my x's and line up my whole numbers. Now, if I add up the columns, does anything cancel? Nothing will cancel yet. And so I need to multiply this equation. Oops, wrong equation. I need to multiply my linear equation by -1. When you multiply by -1, it changes the signs. I'm going to eliminate the y every single time. I can't eliminate the x because I don't have an x squared. If I'm going to eliminate the x, I also have to eliminate the x squared, and I don't have anything that'll make that eliminate. So I will always be eliminating the y. When I add up this column, I get 0. Now it's simply a quadratic equation. There are 3 ways to solve a quadratic equation: completing the square and formula, and the easiest way is factoring. So I multiply the first number times the last number, and I get a -4. Which pair is going to add up to get my -3? Will that add up to get a -3? I'm going to use my shortcut factoring because this is 1. Next, I'm going to solve it. Another name for solution is 0 because I put this equal to 0 and I solve it. Subtract 1 from both sides. That was ugly. And add 4 to both sides. But I'm not done. Because what this equation right here represents is a parabola. What this equation right here represents is a line, and I'm finding 2 intersection points. I am finding 2 points. This is -1, and this is 4, and what else do I have to find? I have to find the y value. You can find the y value by going back to the original equation, but I'm going to show you another way. Because some of you could get the x values, but then you would make sign mistakes on the y values. So, would you please get out your calculator? In the y equals part of your calculator, please put, it really doesn't matter which one, in the y equals part of your calculator, please put one of your original equations. I usually use the linear equation because less chance to make a mistake. And look at the table. Second graph. What lines up with -1? That was a -1? What lines up with -1? There's your point. What lines up with 4? 6. If you put in both equations, this is a way to check. X squared minus x minus 6. Look at the table. Do you see that you have the same number right there? That's a way to know it's an intersection point. Do you have the same number right there? That's an intersection point. -1, -4, and 4 and 6. Those are your solution points. You can't stop there. You have to find the y values, just like we were doing when we were solving linear equations. So do you think that helps to use the calculator to find the y? A lot of you were getting this one correct and then making a sign mistake on that one. If you type this into your calculator correctly, the calculator will not make a sign mistake. Did you hear what I said? If you do what? You have to type it into your calculator correctly. Okay. Example number 2, before I can line up the columns, you see that this says y equals? So that means I need to add 3 to both sides, so this one will say y equals. So this is going to be y equals x squared minus x minus 12. This is going to be y equals x plus 3. Now if I add up the columns, is anything going to cancel out? I need to multiply this by -1 and this by -1. So I multiply this by -1 and this by -1 and this by -1, and then I add up the columns. Now, is the y going to cancel out? Every single time you're going to cancel out the y. X squared minus 2x minus 15. So you multiply the first number times the last number, and you write down the factors of -15. Is there a pair that could add up to equal a negative 2? Since this is equal to 1, I can use the shortcut factoring. 0 equals x plus 3, x minus 5. 0 equals x plus 3, x minus 5 equals 0. X equals negative 3 when you solve that. X equals positive 5 when you solve that. I have to find the solution point. Not just the x's, but the x and y's for the solution point. So you can put in either equation, x squared minus x minus 12. Look at the table. Negative 3 matches up with 0. 5 matches up with 8. Those are your solution points. So this matches up with 0, and this matched up with, did I say 8? Those are your solutions. The solution has x and y, and another x and another y, if it has two solution points. At this time, would you please look at your homework paper? Please complete problem number 1 on your homework paper. We're going to solve this by elimination. If we're going to solve this by elimination, we need to line up the columns. So what are we going to do with this negative 6 first? Any questions on problem number 1? I bet there may be some questions on problem number 2. So, would you please skip on over to problem number 2 if you're not quite finished with problem number 1? I line up the columns, and then I multiply this by negative 1. If I multiply this by negative 1, it makes this one negative, and this one negative, and this one positive. And I add up the columns. What happens with the y's? And that is a 0. I should see 0 equal on every single problem at this step. And the x squared comes down, minus 5x. What happens to the 2's? Plus 0. It is not a trinomial because it doesn't have a term right there. It has a binomial. There's two ways to factor a binomial. Either it has a GCF or it's a perfect square. 5's not a perfect square. So what's the GCF between those two? X. Can I factor out an x? 0 equals x. If I take an x out of that, this has two factors, this factor and that factor, either x equals 0 or x minus 5 equals 0. Well, I don't need to solve that one. I already know that x equals 0. Add 5 to both sides. My two x's are 0 and 5. Now, some people on their test, whenever they got a 0 for an answer, they said no solution. 0 is a solution. 0 is a number. 0 does not mean no solution. And so on your, using your calculator, you can put in either one of your original equations, and so I've already got the x squared in there, so I'll already just go ahead and change that to 4x minus 2, and look at my table. 0 matches up with negative 2, and 5 matches up with positive 3. 0 and negative 2, 5 and positive 3. I think that's going to help you get the sign right on this one right here. And so this is a negative 2, and this is a positive 3. Okay, try the next problem on your homework page. On your homework paper, problem number 3, did you add the x to both sides? Did you multiply the linear equation by negative 1? Now, this right here, this one didn't have a 0 term, so I put in a 0x so I could line my columns up correctly. And so that's what you would get when you add the columns, and when you multiply the first number times the last number, you get a 3, and those are the factors of 3. Can any of those factors add up to get me a negative 1 right here? No. What does that mean? Actually, it doesn't mean no solution. It means no real number solution. We could put it in the quadratic formula and solve it with the quadratic formula and get an answer that's imaginary that has an I in it. Aren't you glad we're not going to do that step? But it is possible. It is not technically correct to say there's no solution. There's no real number solution. Please go back to your notes and let's do example number 3 in your notes. In example number 3 in your notes, I'm going to subtract the x from both sides. So this is going to be y equals negative x squared plus 3x plus 4. The second equation is going to be y equals negative 8x plus 8. Do you see that this time the x squared is negative? When and only when the x squared is negative, I'm going to multiply the x squared term by the negative 1, because I don't like to try to factor it if there's a negative sign right here. So this time I am going to multiply this equation by negative 1. When multiplies by negative 1, it changes the signs. The y's zero out. The reason I multiplied this x squared term by a negative is so right here this would be a positive. And then you add up the columns. These are the factors of positive 4. You multiply the first number times the last number, and so this pair is the pair of numbers that are going to add up to equal a negative 4. So this is going to factor into x minus 2 and another x minus 2. So what's the answer for this one going to be? When you solve that, what are you going to get? Positive 2. What are you going to get for that one? So you're not going to get 2 unique answers. You're just going to get one answer. You are going to plug the 2 back into the original equation. You can do that with your calculator, and that is what the answer is going to look like. The reason that's the answer is because if I graph this first parabola, it's going to look like that. Does anybody know why I drew it pointing down? When there's a negative sign out in front, what happens? Points down. And so the line is going to be coming across like this, and there's only going to be one intersection point on this kind of problem. We're going to save that next example for tomorrow, and right now I want you to work on the front of your worksheet. Problems 1 through 6 are due before you walk in the door to this class tomorrow. Problems 1 through 6 are due before you walk into this class tomorrow. We will finish this worksheet in class tomorrow, and we will also have a quiz on this tomorrow.